Hello student. Yesterday we have studied up to parallax method. Now today we are going to study the measurement of distance to star. Sun is the star which is close to the earth. The next closest star is at a distance of 4.29 light years. Measurement of size of a planet or star. If d is the diameter of the planet and the angle subtended by it at any single point of the earth is called angular diameter of the planet. Alpha be the angle between the two directions when two diametrically opposite points of the planet are viewed through a telescope as shown in the figure 1.4. Capital D be the distance of the planet. So alpha is equal to small d upon capital D, or small d is equal to alpha capital D. Measurement of very small distances. When we intend to measure the size of atoms or molecules, the conventional apparatus like vernier caliper or screw gauge will not be useful. Therefore, we use electron microscope or tunneling electron microscope to measure the size of atom. 1 Angstrom unit is equal to 1.496 into 10 raised to 11 meter. 1 light year is equal to 9.46 into 10 raised to 15 meter. 1 per second is equal to 3.08 into 10 raised to 16 meter is equal to 3.26 light year. A light year is the distance traveled by a light in 1 year. So 1 parasecond is the distance from 1 AU subtend an angle of 1 second of R. So R is equal to 1 AU upon 1 second degree. Example, a star is 5.5 light years away from the earth. How much parallax is arcsec will it subtend when viewed from two opposite points? So two opposite points, that is A and B, along the orbit of the earth are 2 AU apart. So AB at a position of a star is AB upon distance of the star from the earth, AU upon 5.5 Ly, that is 2 into 1.496 into 10 raised to 11 meter upon 5.5 into 9 light year. Ly means light year. 9.46 into 10 raised to 15 meter. So while solving we will get 5.75 into 10 raised to minus 6 rad, or 5.75 into 10 raised to minus 6 into 57.297 into 60 into 60 arc second is equal to 1.186 arc second. Next example, the moon is at a distance of 3.84 into 10 raised to 8 meter from the earth. If viewed from two diametrically opposite points on the earth, the angle subtended at the moon is 1 degree 54 minute. What is the diameter of the earth? Solution, that is angle subtended. Theta is equal to 1 degree 54 minute is equal to 114 minute. 1 degree is equal to 60 minutes. So 60 plus 15, 4 is equal to 114 minute. 114 into 2.91 into 10 raised to minus 4 radian is equal to, after solving, after multiplication, we will get 3.317 into 10 raised to minus 2 radian. Diameter of the earth is equal to theta into distance to moon from the earth. 3.317 into 10 raised to minus 2 into 3.84 into 10 raised to 8 meter. So after solving, we get 1.274 into 10 raised to 7 meter. Next point, that is measurement of mass. Since 1889, a kilogram was the mass of a shiny piece of platinum iridium alloy kept it in a special glass case at the International Bureau of Weight and Measures. This definition of the mass has been modified on 20th May 2019. The reason being that the carefully kept platinum iridium piece is seen to pick up microparticles of dirt and is also affected by the atmosphere, causing its mass to change. The new measure of kilogram is defined as the terms of magnitude of electric current. While dealing with the mass of atom or molecules, kg is an inconvenient unit. Therefore, the mass is measured in atomic mass unit, and it will be easy to compare a mass of any atom in terms of mass of some standard atoms. That is, the 1/12 of mass of an unexcited atom of carbon 12 is called atomic mass unit, that is AMU. 1 AMU (1.660504.2 into 10 raised to minus 27 kg. Then measurement of time. The SI unit of time, that is, time is measured in second. From many years, duration of one mean solar day was considered as a reference. A mean solar day is the average time interval from one noon to next noon. Average duration of the day. One day have 24 hours and 1 hour have 60 minutes and 1 minute have 60 seconds. So the mean solar day 24 hours is equal to 24 into 60 into 60 is equal to 86400 seconds. So accordingly, second was defined as 1 upon 86400 of a mean solar day. The cesium atomic clock, the second is taken as a time needed for 9192631,770 vibrations of the radiation, that is the wave. So cesium is 133 atoms. Dimension and dimensional analysis. So in this point, derived physical quantity can be expressed in terms of some combination of 7 basic or fundamental quantities. So dimension, that is represented by symbol L for length, M for capital M for mass, T for time, K for temperature, and I for current, and C for luminous intensity. So dimension of physical quantity are the powers of which the concentrated fundamental unit must be raised in order to obtain the units of the given physical quantity. So velocity is equal to displacement upon time. Dimension of velocity, that is L upon T, that is L1 m0 t minus 1. So some dimensions are given. Density rho is equal to m upon v, that is kilogram per cubic meter. Dimension L minus 3 m1 t0. Second one, that is acceleration is equal to the rate of change of velocity with respect to time, that is meter per second square, m per s square, L1 m0 t minus 2. Third one, that is momentum. Momentum is equal to the product of mass and velocity, that is kilogram meter per second, kg meter per second, L1 m1 t minus 1. Next one, force is equal to mass into acceleration, kilogram meter per second square, that is L1 m1 t minus 2, or Newton. Impulse J is equal to force into time, the product of force and time, that is Newton second. Impulse, that is force into time, Newton second, L1 m1 t1. Next work, force into displacement, joule J, that is L2 m1 t2. Kinetic energy 1 by 2 mv square joule, same, that is L2 m2 t2. And pressure F upon A kilogram per meter square, L minus 1 m1 t2. So this is for homework. This we have to by heart, and next period you will see next point.